about securing your intelligent apps with Microsoft Entra. So I'm Pamela Fox, and I'm from the Python Cloud Advocacy team at Microsoft, which means I do very much like Python, but I try to love other languages too.
I'm Matt. I'm from the AI search team at Microsoft.
And I'm Delimarsky. I'm a tech lead for Microsoft Authentication Library, and my job is to make auth easier. Not easy, easier.
All right, and we are actually going to start with Den to give us a little primer about identity and access management.
Thank you, Pamela. So identity and access management. So as we called out from the very beginning, it's not really easy. A lot of folks struggle with a lot of the concepts and tying things together, especially when it comes to web applications, mobile applications, like it doesn't matter. So let's start with some concepts. Two things that you need to familiarize yourself with. So one, there is authentication. And authentication is, in security, the process by which we confirm that the user is who they say they are, right? So if you're going to, I don't know, xbox.com or outlook.com and log into your MSA, the Microsoft account, we're verifying that if you're typing in your email and a password, like, are you actually, let's say, den@outlook.com? Authorization, on the other hand, is ensuring that you have the right level of access to the resources that you're asking access for. So, more concepts. Authentication usually uses a protocol called OpenID Connect, or you might have heard it as OIDC. And usually different providers implement endpoints that you can call through REST APIs that you can request, you can pass some information like credentials and say, is this the user who they claim to be? So if I log in with den@outlook.com, I verified that with Outlook, is this actually Den? Then there is the authorization framework that is implemented through the OAuth 2 protocol. And authorization is actually the application logging in on my behalf and saying, Den is trying to access their Xbox profile or their Azure resource. Are they allowed to do so? Now, as you go through the presentation today, there's going to be some terms that you need to also be aware of, things like auth flow. And auth flow is how exactly you are logging in to the application. So there's a multitude of them you probably have seen. There's auth flows that require you to enter your username and password. There's an auth flow that requires you to log in with, let's say, a device code, like IoT devices, or I keep using the Xbox example, where you don't really have to type the entire password. You get a code, you then go to your browser, you enter the code, and then you're authenticated. The authorization server is the resource or some server running somewhere that verifies that this user that you're authenticated with can actually get a token. It's a service that issues the actual token. The client is the application that requests access to a protected resource like Azure Key Vault or Azure Storage. So it can be a web app, it can be a mobile application, or it can be a service. The resource owner is whoever owns the resource you're trying to access to. So in the case of Azure Key Vault, or in the case of Azure Storage, it is Azure. The resource server, on the other hand, is the actual container that runs the code that you're trying to access and that contains information that the user requests you. So all this out of the way, the last thing I'll mention here is that there's three things you need to be aware of in terms of authentication and authorization. So there's different application types. SPA, or the single page applications, they deserve their own little carve out because they act a little different than all the other applications, and they're basically what the name is. They're single page applications that don't need to re-request more and more information from the server. You run it once, and then the view updates. Public client applications, and you'll hear it in the OAuth kind of stack of concepts, are applications that cannot securely store secrets. These are your web applications, like websites, they're your desktop apps, mobile apps, and they can't store secrets because all those apps can be reverse engineered. Somebody can dump the APK from your Android device and look inside and see, well, what's the certificate you're using? What is the secret key? So we call them public client. By default, they cannot store a secret. And then there's confidential client applications. And these are the applications that run on the server. So your end user never actually has access to the credentials there. So you can use certificates, you can use secrets, you can use managed identities, and the user will be none the wiser because they never get actually access to them. So now, to see all this in action, I'll hand it off to Pamela.
All right, thank you, Den. And if you already forgot everything he said, it's totally fine because we do have documentation about all this. I actually binge read it on the airplane, because what else are you going to do on an airplane? So I think OAuth is pretty tricky, so it's something I have to constantly refresh myself, even as I'm coding it with it every day. So I'm going to start off with talking about how we can add user authentication, like sign in, sign out, to our apps. So we're going to start off with an AI app, okay? So I've actually got this running locally or inside GitHub Codespaces locally, right? So here I can say, all right, write me an epic story about a unicorn crashing a build conference. Okay. And then it's gonna start typing. And what's this doing? It's sending off a request to the OpenAI servers and getting back a response. Let's see if I can see what is happening here. Oh, and I'm logged out already. All right, I will log back in. So we're gonna see a little Entra in action here. Oh, there we go, and then log in. So this is the device code. Remember we were just talking about different flows. This is called the device code flow. So if you are working in GitHub Codespaces, you do actually have to use device code flow. So it means that I have to go through a whole rigmarole in order to do this, which means I have to remember my ridiculously long but super secure, there we go, password, there we go. All right, and then there's gonna be a couple more requests. And then we got to go to MFA. This is why you do not want to implement this yourself. This is why you want to use Entra to do this for you, right? Because who the heck wants to implement that huge number of steps? Did my Face ID, I got biometric, I got a code. Oh my gosh, why? That's so hard. All right, logged in. And then let's see if now it will be able to access my Azure OpenAI. Okay. All right. Try it again. Story about unicorns, go. There we go. I get more and more curt as I go on. There we go, okay. And so we can see it's streaming in the response from the server. And if we look at the server code, it's actually a very short amount of Python code, right? So making a request to the Azure OpenAI, and getting back and then streaming it. So we're actually yielding one chunk at a time. This is a best practice in terms of user interface. And then on the front end, I'm using this new SDK that just came out, the AI Chat Protocol SDK, which makes it super easy on the front end to consume a stream so that you don't have to figure out how to code streaming yourself. So I initiate the client and I just do a little for loop to get back each chunk and display each chunk at one at a time. And there we go, we got it. So this does not have user auth yet, right? You can say that it just says you, okay? I wanted to actually show my name. So I want to go from that app to an app that knows who I am, right? I want to add user sign in to it. So that's what I'm going to show in my section. And what I'm really going to focus on is how to do this automatically, right? So we're not going to show any clip cops. I hate clicking around the portal. Maybe some of you love it. I hate clicking around the portal. I always get something wrong. I always forget what it is I did. I can never remember that magical incantation again. So everything we show you has been automated with code so that you can then go take it and just run, a couple commands and then hopefully be good to go. So that's our big focus. So the first thing that we need to be able to do is, in order to be able to use Microsoft Entra, user authentication, we need to create a Microsoft Entra application and then create a service principal for that application. And you can think of the service principal as actually just being like an instance of the application. So that's what we need to create so that it knows who we are and is comfortable doing these flows with our application. So here is code from the Python graph SDK. There's very similar code in all your favorite languages. And it'll actually probably look pretty similar to this too, because it's all object-oriented. But basically, we create a graph service client. We say, okay, this is the application we want to make. We need to tell it stuff like redirect URLs, where the redirect is going to go back to. We need to tell it what scopes we're interested in. So if we want to do a user auth, then we're going to ask for the OpenID scope, and that means that we're going to get back the profile. And if we want to be able to like refresh tokens, then we ask for the offline access scope, and that'll let us refresh tokens. So this sets up the application with, everything. Like we're telling, this is all the stuff we need to be able to do authentication. And then we also do need to make a way of credentialing ourselves for that application. Right now, there's two options. There's secrets and there's certificates. Both of those options aren't great because you have to store a secret somewhere, and I hate having to store secrets. It gives me the heebie-jeebies, right? I will show a way that's going to come out soon that you'll be able to use instead. But for now, we use a client secret, and then we store it in a key vault, and then retrieve it from that key vault. So we set up that. You could also set up a certificate if you want to do that. All right, so now we've got that application registration. Now all we have to do is implement OAuth. See? Easy, easy. So this is the classic OAuth 2 flow. And this is actually just OAuth 2. This diagram here shows you the OAuth 2 authorization code flow and what it looks like. Now, to make this OIDC, which is how we do user sign in and sign out, we just add that our scope should be OpenID. We say, okay, we're doing this OAuth flow, and we want the OpenID scope. So that tells the server, like, hey, we're doing an OIDC login here. And then when the server eventually comes back at the very end, when we exchange our authorization code for a token, it's going to give us both an access token and an ID token. And that ID token will contain what we want. That's going to have the good stuff, the name, the email, the stuff that's available in that profile. So really, like OAuth 2 versus OIDC, OIDC is just a particular subset of OAuth 2 that's going to give us that experience and that information that we want. So this is what we need to implement, all right? Now, this still looks like a lot to implement. So what can we do? We've got a few options. The first option is that if you are deploying to Azure App Service or Azure Container Apps, you can use a feature called the built-in authentication feature that will do that whole OAuth dance for you. It'll take care of the redirect and the token exchange and all of that for you. And that's really, really cool. So if you are deploying on those platforms, you can take advantage of that feature, and that will give you sign in, sign out on your deployed application in production. The second option is that if you need the sign in, sign out to work anywhere on any host, maybe you're on some other Azure host, or maybe you're not hosting on Azure or something, or maybe you're just developing on localhost and you want to be able to have sign in, sign out there, then you will need to use an SDK, the MSAL SDK, in order to set up this flow and do the particular steps. So I'm going to show both options here. So first one is using that built-in authentication on app service or container apps. This is always going to be easier, so if this does it for you, then that's great. So the first thing we need to do is configure that built-in authentication feature. So what I'm showing here is a language called Bicep. Bicep is an infrastructure as code language. It's similar to Terraform, if you've heard of Terraform, except Bicep is particular to Azure. Also, if you've heard of ARM, Bicep is just compiles down to ARM. So Bicep is like syntactic sugar for ARM. ARM is JSON, right? So if you think about it, you've got an ARM, and then it's stronger, you get a bicep. That's the joke. Okay, so that's Bicep, but I absolutely love it. I became such a fangirl because when you have Bicep, you can declare everything you want to make. So when you've got like 10 different resources that you need to set up, instead of having to like click through the portal or write an Azure CLI script, you can declare everything in Bicep and then run a single command that's going to provision everything. And it's even going to be able to provision things in parallel based on like the dependency graph of what can be provisioned when. So anytime I can do something in Bicep, I do. And it's also language agnostic. So if you have people at your company, some of you are in Python, some of you are in .NET, you write all your infrastructure as code in Bicep, and you can all agree to either love or hate Bicep. But then at least you don't have to fight over your like main language, right? So this is the configuration for container apps authorization built-in feature. So you can see we tell it like, oh, okay, if someone's unauthenticated, you need to redirect to login, because you also have options for if you do want to now allow anonymous, it's an option. And then we set up our identity provider, and we say we're using Entra. So we say Azure Active Directory, formerly known as. So we say that. We specify our client ID. So that's the client ID from the app that we made in the previous step, the Entra application registration. And then we tell it where our client secret is stored. So we store the client secret in a Key Vault secret and inside the container app secrets, and we point it at there so it knows where to find it so that it can do, set up those credentials. And then finally, we tell it the OpenID issuer. And so that you can see at the very top where it says, it depends on whether you're doing a multi-tenant or single tenant and all this stuff, but for like your basic single tenant app, it's going to be like the Microsoft.com login and then your tenant ID, and that's where it's going to send everything. So that's what we need to configure at most basic in order to set up this feature. And yeah, let's just check it out. So, all right, here we go. This is the same app, but now it's deployed. Wow, look at that. There's my name. Acronym for build conference, please. You don't have to say please to LLMs, they don't care. But more Microsofty. Let's see. It's pretty similar. All right, so this is running on Azure Container Apps. So let me show the flow. So I'm going to attempt to log out, which always scares me in these demos, because what if the logout doesn't work? But okay, I'm going to log out. All right, hang on a moment while we get logged out. And there we go. As you can tell, I did not code that web page. Doesn't look like the rest of the site. But you can see that this is a container app special URL .auth. That's the built-in feature. And then I can go back to my main page, and it's going to force me to log in. So if you just need to make sure there is a login gate in front of your page, you just do this built-in auth, and then it'll force people to log in. I'm logging into my special tenant, which I think only Matt and I are in that tenant. It's a very special tenant. We're looking for more people to join it. Oh, it doesn't recognize my face? Oh, come on. Here we go. All right. And there we go, logged in. So that is the built-in authorization experience for container apps, and you can do the same thing on app service. All right. So that worked. Now, the question is, how the heck did I get my name, right? Because I just said the container app says everything for you, and does this whole dance, so how did I even get my name? So what happens is that container apps will inject information into special headers, and then you can inspect those headers and extract details that were conveyed during the authorization process. So I'll show you the code for that. Is that when we go to the index page, we extract the username. So we look for this special, super special header, and it makes sure that only it can set this header. So it's going to be X MS client principal. We get this token out of there, and we can extract the claims from the token. And in this case, we extract the name from there. So we could also extract other stuff that we got from that OADC process. So that's how we can have the container apps do that whole OAuth dance and still get back information that we would normally get from the ID token. Okay, cool. So that works. And if you do want to get started with that, you can go to this sample here that's linked from the slide, and just run AZD up, and maybe it'll work. Should work. All right. So I also wanted to show external ID. So Entra external ID is how you can let people, just anyone in the world, come into your app. And super cool if you want to make something that's consumer facing, right? So here I have the same app, but now it is deployed in my external tenant. So here's my external ID tenant, and I can set up the identity providers. I did this all via Python, like a good person. But I can show you it in the portal, right? So I've enabled this email one-time passcode flow, which is a super popular flow. This is what I use to log into most apps these days, is you just get a one-time passcode on your phone. So if you want to enable that kind of experience for your app, then you can use Entra external ID. So that's what I've done here. So once again, I will attempt to log out so I can show you this flow. So I'm going to log out, and you can see it's a little different looking, right? You can see my trial tenant, and you can make all this a lot fancier looking. Hopefully you can also make that fancier looking. I actually haven't looked into that yet to see how you customize that. I'm sure the Entra team can tell me. All right, so now I'm going to sign in. And now you'll notice I'm picking what looks like a Gmail account. It's not really a Gmail account. This is a Microsoft account I happen to be logged into that has my Gmail address. You could configure this with Google if you want Google login specifically. You can see that that's an option here. I didn't configure that, so here is just anyone, with anything. All right, so we just sent a code. So now I'm going to go over to my Gmail and hope that everything is legit. Pretty legit. Okay. All right, and here's my verification code. And then I can put it in here. And so that is the one-time passcode experience. So if you're making something consumer-facing, you want an easy way for them to log in, you could set up this one-time passcode, and it's a really similar setup. It's the same repo as the other one I showed. And then you can, there we go. I want ponies. I'm sorry, I have a 4-year-old and a 1-year-old, so you have to excuse me. Okay, so there we go. So that is set up. All right, so the next step is how would we use the MSAL SDK? So if we're going to be doing this ourselves, then we do have to code this flow here. And specifically, we need to do the parts that I've highlighted in purple, right? So we need to, we get a request from the user, then, okay, the user's not logged in. We need to initiate that authorization code flow. And then when it comes back to our redirect, we need to handle that redirect. And in that redirect, we grab the authorization code, we exchange it for our ID token, and then we get back the details from that ID token. So you can use the MSAL SDK that is available in all your favorite languages. And so here we would make a confidential client application, because this is running on our server, so we can pass in our credentials and say, here's our confidential client application. Here we're going to initiate the flow, and this is the redirect URI you should go back to. And then a lot of stuff happens, and then we do the final leg of the OAuth dance where we exchange that authorization token for the access token. That's still going to be a lot of work. So to make it easier, there's this open source package called Identity, where it already off the bat has support for, this is in Python, so it has support for popular Python frameworks, Flask, Django, Core, probably Fast API coming soon, and we just add a decorator. So that's a really nice way that you could just set this up, add a decorator, and just say this route requires login, and then it'll just work. So that's what I've got running in the browser over here. So what you can see is that this is a localhost URL, right? Localhost 50505, and you can see that I am logged into it. So now I'm able to have the login, logout experience locally. And that's because I'm actually using that MSAL SDK inside my own code. So if you do need the local development experience, or you need to deploy to a host that's not Container Apps or App Service, then this is what you want to use instead. And once again, you can use this and typically do something like this in all your favorite languages. You can just check the documentation. For Python, you can get started with the sample we put together. And then it'll also work once you deploy it, right? So the great thing is if it's working locally, it's going to work once you deploy it. All right, upcoming improvements. So I told you, okay, when you make an application registration, you have to use a secret or a certificate, but we don't like to be storing secrets, right? That can lead to shenanigans. So this is a way that we're going to be able to not use secrets. So first of all, we can now use Microsoft Graph Bicep in order to programmatically create graph applications in Bicep. So that Python code I showed before with the MS Graph SDK, we can now do this in Bicep. But then the next step, which is really cool, is that we can use a managed identity as a federated identity credential for that application and completely avoid having client secrets or certificates. So this is so cool. When this worked, I was shocked. So this is I guess the announcement. See, we are announcing something, right? This is not available yet for general use yet, but it is coming very soon down the line. So look forward to this. It means that we'll be able to move away from client secrets and certificates and be able to start using managed identities for everything, which is, of course, all of our goals in life, is to do that. So this is super exciting. You can see my PR that adds it to a repo if you want to see how it would work once it's supported. And then when you want to use it with built-in auth, instead of pointing it at an actual secret, you would just tell it like, hey, use the managed identity. So you'd literally put that exact string, and it would be like, oh, okay, I'll just use the managed identity. So that's super cool. It shows you don't need to actually have a client secret. It's just going to use your managed identity. And you'll also be able to use it with like the confidential client application and all that stuff. You'll just be able to pass in a managed identity. The big drawback of this is that you won't be able to use this locally, because locally you don't actually have a managed identity. So this is going to work when deployed. It's not going to work locally, but still, for lots of applications, it's going to be really, really exciting, and I'm just super excited about it. Okay. All right, good. So that was my spiel about how to add user auth. Now, and to be fair, like we call this like securing your AI apps with Entra. You can use everything I just showed. It doesn't matter if you're doing an AI app. That's just about how you can add user auth to anything. We made it an AI app because everyone loves AI right now, but you can use that technique for any app. It could be a completely non-AI app whatsoever. But now Matt is going to go into something very AI specific.
Thanks so much, Pamela. I appreciate it. So in the past 20 minutes, we all have become Entra experts. We understand a lot about authentication. And what we want to do is we want to bring it back to kind of the AI use case. So I have a very similar application to the one Pamela showed. This is actually an open source sample. You can deploy it yourself in your own tenant and try it out. I essentially want a kind of chat style application where I'm chatting with an LLM. In this case, I'm using GPT-3.5 but I want to talk about my documents. And I want to add the concept of a user identity. So if I am just asking a generic question, like what's included in my 𝗦𝗽𝗲𝗸𝗀 plan, but I'm not logged in, I don't really want to give a response to the user. So I ask the LLM a question, and it kind of just gives me an answer like, I don't really know, I'm sorry. But when I'm logged in, I want to use that identity to give a different answer. Now, oh, I know who you are. I can tell you about the 𝗦𝗽𝗲𝗸𝗀 plan, and I can see that I actually cite in a document, so I can actually go and look at that. So what's interesting about this is it's a very similar setup, but there's a couple extra steps. So there's a very common pattern when we talk about AI applications today. You typically want to kind of build a front end separate from your back-end application. A very common pattern that has emerged is I've got a single page application. In my case, I use TypeScript with React. And what I found is that, I want to be able to log in. I want to do everything locally on the client. Well, turns out that you actually need a separate Entra ID application for this use case. My app, my backend app, I'm actually running on a local host in the console. This also has an app associated with it in Entra. And we have an interesting problem. We now have two Entra apps, and I need to be able to connect them together. So a very common flow that we use is called on behalf of. I think I've lost my slide.
Yeah, it keeps going back and forth between the main thing and his thing. I don't know. Is it? No. Jiggle it.
OK, here we go. We're back. So basically, what I need to do is I need to use a very special OAuth 2 flow called on behalf of. And Microsoft Authentication Library SDK makes it super easy. It's literally just one line of code. But essentially, what I do is I log in on the client side, and then I pass that token through an authorization header to the backend. I validate that a token is indeed from the client app, and then I use the on behalf of flow to exchange it for an API token for my resource. Once I've exchanged the token, I'm able to actually call any API I want on behalf of the user, provided I've asked for that in the application manifest. So this is a very powerful flow, and it's very commonly used in apps like this where there's both a front end and a back end as distinct components. So let's kind of rewind a bit back earlier in the presentation, and we kind of talked about tokens. Tokens are super powerful. They're issued by Entra. You don't really need to worry about kind of like the mechanics how they're issued. But the great thing about tokens is that they can contain arbitrary data. And this arbitrary data has a lot of information to say about the users that's logged in. I've taken a token and I've kind of cleaned it up, and I'm showing you some example claims. Claims are just key value pairs. So for example, just by looking at the token, I can see the display name of the users that's logged in. I can see something called their object identifier. This is super useful for authentication because it's a unique GUID that's directly kind of corresponding to the user account. Nobody else is going to have this. It uniquely identifies as a user. I can also get group memberships. So in Entra, you can define this kind of concept called groups, where rather than trying to refer to users one by one, you can say, oh, this user is part of this group. And it's basically a very powerful way of saying, hey, rather than having to refer to individual users, I can basically refer to collections of them. So we now have a problem, right? I've got a chat app. I've got a bunch of documents I want to talk to. If I'm using AI search, I've got a concept called an index. An index is kind of just a collection of documents you can search over. So the general way this works is I have a question, like what is my Northwind Health Plus plan? I search my index of relevant documents, and I send that back to the language model to kind of synthesize a response. But I kind of want to go a bit deeper, right? I don't want to give back all the documents. I just want to give the ones the user has access to. So I can do this very simply in AI search by just adding an extra field. I'm going to add a collection of strings called object identifiers and a collection of strings called groups. And I'm going to use this special attribute called filterable. AI search doesn't just support full text and vector embedding search. It supports a really powerful concept called filtering. When I use filtering, what I can do is I can now really efficiently search these object identifiers. I can restrict my search so that I'm not just searching for Northwind Health Plus plan in my index. I'm going to restrict that search to only go over documents that are associated with that user or the user's groups. So doing this way allows us to connect those token claims back to the search index. So we've basically, what we've done is we've kind of had Entra takes care of authorizing the user, and it takes care of telling them who we are. And by using this filtering, we've basically implemented authorization. So we're now saying, hey, we know who you are. We know what you have access to based on what's stored in the search index. I can also really easily update this because access control isn't static. Maybe one day somebody has access to a document and the next day they don't. Things change. And AI search supports the ability to update kind of single properties in the documents. So if I've got a lot of properties in my document, I don't need to re-update all of them. I can do something called a merge-based update, where I basically give it, hey, for the document about Northwind Health Plus plans, here's the new list of users that can access it, and here's the new list of groups that can access it. So it's kind of a complete end-to-end story for connecting token claims and all that great stuff we learned about Entra back to AI search and your chat application on your documents. There's another Azure service called Data Lake Gen 2 Storage, and it's a very powerful extension to storage accounts. What it does is it allows you to associate access control with directories and with files. So now what I can do is I can say basically in a storage account, I can have a giant list of documents, and each one of those documents themselves can have access control. In our sample application, we provided a lot of sample code that basically shows you how to parse this access control information and update the Azure Search Index with it. This is a really powerful concept because it allows you to define your access control information in a single place and kind of replicate it out to the AI Search Index. So you don't have to worry about keeping them up to date yourself. You can kind of have a single process that synchronizes the access control from data lake storage directly to AI search. There's a very easy to use Python SDK for Data Lake Storage Gen 2 that basically allows you to fetch access control lists for individual files in case you want to do a kind of out-of-band update. And you can also deploy this as a custom skill in the Azure Search Index pipeline so that you can actually automatically update it on a schedule. There's two general paths towards updating your data with access control information. As I mentioned before, what you can do is you can ingest the documents directly from a data source that has access control information. And then once the index has been updated, all your filters will work just automatically. Sometimes your data is stored without access control information. You might have kind of old documents that are stored in independent space. But using the merge technique I showed earlier, you'll be able to kind of join it against that access control store. Sorry, I lost the slide. You'll be able to join these documents with the access control information and update it separately. It really depends on your use case and how your chat application is set up, but either approach is valid. Basically, what you want to do is you want to make sure that documents enter the search index either with the access control information already assigned, or there's like a very short time period that you need to update it. There's another valid question that comes up a lot, which is, you're more than welcome to use an index per user rather than this filtering approach. The only problem with defining an index per user is that AI search services have a finite number of indexes per search service. We offer something called a high density tier in our standard 3 service, the S3, which offers 1,000 indexes per partition, and you can scale up to 3 partitions. The only drawback of using this tier is that you only have 100 gigabytes of data per index. So for applications with large amounts of users, we highly recommend taking the filtering-based approach and combining it with an Entra app on the back end and the front end so that you can implement this authentication and authorization yourself. Search filtering is very powerful. You can have tens of thousands of user IDs or group IDs associated with a document, and you'll get kind of very quick search results. So going on to next steps and just general questions and answering, Pamela, do you want to take us over?
All right. So, so we showed some samples there, and we'll have more links to them. Other things you might want to consider in terms of security is using managed identity to access all the Azure services, at least all of them that do support it. So all of the samples that we have do use managed identity whenever possible. So that means never passing in an API key, okay? So that's always what we recommend. And that does use Entra behind the scenes, right? It is actually doing an OAuth dance behind the scenes there in order to avoid using API keys. So we recommend that, and we've got documentation about that you can read if you're new to managed identity. Another thing you can do is use a virtual network and private endpoint to isolate your AI apps. Matt actually just did a massive pull request to add it to that demo that he was showing. And so that's putting everything inside a virtual network and setting up private endpoints for everything, the cognitive services, the blob storage. Like, you said you had fun with that, Bicep, so I'm glad you had fun with it. But that means, like, yeah, you got a great example of how it is you can actually put everything inside a virtual network. So if you are making something for the enterprise, you definitely want to consider that, because that means it's not going to escape your network at all. So these are the samples that we showed today. There's the one with the built-in auth, there's the one with the local auth, and then there's the RAG chat sample. And so this can, shows you the range of things that you can do. The interesting thing about the RAG chat sample is that it uses both built-in auth and local auth. Because I think it was because originally you implemented local auth, and then James was like, hey, why don't you implement built-in auth too? We're like, okay, sure. So you get the option. Like, if you wanted to turn off one or the other, you could. But that RAG chat sample, it just does everything. It's like the kitchen sink. So if you're looking, to figure out how to do every possible thing, it's in there. But we also have, these smaller samples to get started with. And there's lots of other AI samples that you can get started with too. And we're trying to make our samples available generally in Java, JavaScript, Python, .NET. Those are the top languages we, hear that developers want. So we've got samples for assistance and OpenAI and fine tuning and model catalog and all that stuff to help you get started. Den.
All right. Thank you, Pamela. Well, Pamela and Matt made auth and auth-z really exciting. Let's give them a round of applause. That's great. For folks that want to learn more, so we just launched the new Microsoft Entra Developer Center. So go there to learn everything about Entra. And of course, entra.microsoft.com if you want to experiment with it yourself. And then we're very excited about support for Microsoft Graph and Bicep. So you should also check out the documentation there. If you have more questions about Entra, security, how to do auth, authentication, authorization, stop by upstairs. We have a booth in the security section. So big sign that says Microsoft Entra. Go there. And then make sure to check out the session after this presentation. If you ever want to come back to it, we're going to have the slides uploaded within the next 24 hours. That's what I hear. So, all right. Do we have time?
We have time for questions.
Questions.
We do have time. OK, so if you do have questions, just raise your hand and we'll run the mic over to you. Any questions? Oh, back there.
Hi. When will you add the ability to add permissions to user-assigned managed identities in Entra?
User-assigned managed identities. Tell me more. What's the scenario?
So the scenario is users in our org want to access data inside of Entra, and they don't want to use app registrations because of the expiring secrets. They want to use user-signed managed identities because the secrets don't expire.
Yes. So that is what Pamela was referring to as the federated identity credentials. So we are testing that capability internally as we speak. No announcements yet, but stay tuned. That it's coming.
Well, it's like
So I'm able to add user-signed managed identities to Entra, and then when I go in there to permissions, I can't specify permissions. I have to do it through the Azure CLI, writing some kind of ugly scripts to assign, for example, graph permissions. And so there's just not the ability to add that. In Entra, you can, if you have an app registration, you can go in and set API permissions and go in and say graph and assign, all of the permissions that you need. But with managed identities, you can't do that.
Let's chat after this presentation or stop by our booth. I'd be happy to dig into the scenario.
over there. Oh, she's going to run the mic to you. Just make sure everyone on the internet can hear.
Middle.
So for this situation here, how do you do the dev locally then?
You don't. Yeah. I know. Oh, and I had that originally written that you don't. I don't know what happened to it. But yeah, so that is the drawback of it. I have expressed my boo as well to the folks back. We even had a meeting with them where we were like, hey, how do we do this locally? Right now, yeah, we don't, we haven't figured it out.
No, not yet.
Yeah. So that's the thing. I think that when I would use this for is that if I'm doing built-in auth, where my auth is already only on prod, I would definitely set this up immediately as soon as it's supported because that's straightforward. I'm already not doing local auth. But yeah, the story's getting more complicated so I think one thing you could do is that locally you could, like I was saying in our RAG chat app, we support both MSAL-based local auth and built-in auth. So locally, you could have a dev test scenario where you're using something that has a secret or a certificate, and that could be a different client. Then when you go to prod, you could use a client that's configured with this one. And so your prod client could use managed identity with built-in auth, and your local story could use a client with a client secret.
And that's the go-to story.
Yeah.
Yeah. The dev team is well aware, and this is something that is top of mind for a lot of folks now.
So we had one question from the online audience, and I think it's from Matt. And can we use the same access control that you've shown for OneLake?
Yes. So basically, it's all a matter of if you know how to parse out the access control from your documents. There's two general ways of doing it. Number one, you could just write a simple script that just kind of trawls all your documents and does it. The other option is to use our built-in indexer pipeline, which now supports OneLake. And there's an extensibility point called a custom skill, and you can put that same access control parsing logic in there and just kind of merge it in. Both strategies are equally valid. It's just up to your scenario. But yeah, as long as you understand how your access control is represented, which is really the key part, it's very easy to add it to the AI search index.
Any other questions?
All right.
Cool.
Well, then stop by upstairs. Thank you, folks.